In yesterday's video, we looked at the oblique mercator projection for what is called the stereographic flat Earth model. Now, we're going to be looking at Ronnie and Jason's map of the Awake Souls. They are the ones who named this model, the conceptual model, the SVR. They promote this, believe in it. So I'm testing their map now because it is easier to tile across, whereas the oblique mercator I could not. So with this map here, it makes it more clear how, for example, Australia is still getting some sun from the South Pole when the 24-hour sun is circling there. Without the tiling effect, it was very confusing for some people before. Not everyone was able to actually understand the conceptual model, but with it being visualized, it's more clear. What happens is we can circumnavigate because we can just keep on going and we appear on the other end, if that makes sense. So, like right here, this is not the end of the world. There is no edge. We live in an infinite stereographic virtual reality, according to this model. That is the argument put forward. And we see how stuff such as the 24-hour sun and Antarctica makes perfect sense on this model because we have two poles. So it's a very interesting way of looking at this from a whole brand new perspective. So what I still got to do is determine which of the two maps is easiest to mathematically quantify a coordinate system. What that means is, imagine graph paper, and this bottom left-hand corner here is 0. The x-axis is going across left and right, and the y-axis is up and down. So point 0, 0 is right here in the bottom left, whereas point 500, 0 is right here. Point 500, 500, for example, is up here at the center, and then point 0, 500 would be over here on the left. So this is a very basic coordinate system, but what that means is I need to be able to, for example, know right here, if I click on that spot, I can know instantly where the X and Y is. That might be like positions 300 and 200, but I need to now be able to determine what latitude and longitude position that is. So that is where we get into quantifying a model, and we need a mathematical way now to know every latitude and longitude position here so that we can have observers, we can give them a celestial sphere, let them see the sky, and more importantly, so that we can get an accurate ground position for the sun. As you can see right now here, this 24-hour sun in the South Pole is doing a perfect circle. It's just a sine and cosine function against the radius, and that's how you get this orbit. But we see that the lines of latitude aren't actually like that. It's like an oval in some places, in other places it's completely crazy. So we need a mathematical function that can represent this entire map projection, and that may not be possible with this map here. I don't know. We may have to use the oblique mercator projection, and if so, that's okay. But I'm exploring both. Right now, I kind of like this one because it allows the easy tiling. But even as we see here, though, it's not perfect. So the creators of this map did a good job, but not perfect. If we wanted to turn this now into a quantified model that we can use for scientific research, these over here would probably have to align up. I'm assuming that was not intentional by them. But this down here matches up quite nice. And that's all I'm trying to show right now for a conceptual model. How would we have a 24-hour sun circling the south?